Okay, so today I'm going to solve a problem from Pramp. So I got like this problem in one of the interview on Pramp, and I didn't finish it during the interview, so I'm going to finish it now. So the question is called shifted array search. So let me read the question out loud so you guys can hear it as well. So a sorted array of distinct integer shift array. So given a shift array is shifted to the left by an unknown offset. So this is shift to the left by x, and you don't have a pre-shifted copy of it, so you don't have the original copy of it. For instance, the sequence, so example 1, 2. So this would be a sorted array, and then this would be the shifted array. So it seems like it shifted two times to the left. So imagine this array is a circular array. So thinking that it's like this, point to here, point to here, point to here, and point to here, and then you just like shift So this question, it's saying that it shifted to the left, so it's more like it shift backward, to the left like this. So it shifted, so one time it shifted, we should have something like this, and second time we shift it, it's the same as the given. Alright, so given shift array and integer num, implement a function shifted array search. That find and return an index of num in shift array. Let's say this is the shifted array and this is n, and I'm supposed to return an n. If as num is an n shift array, return -1. So and here -1 and false. True have to be 0 to n, where n is the size of the array. Alright, explain your solution and analyze the time and space complexity. So one thing that I want to know is, so this array is some sort, it's not like a random array. It sorted in some way, except that the beginning of the array is not like shorted. So my suggestion would be, like for this case, like in the case of 3, 4, 5, 1, 2. I mean, you can just like loop through the array and find that number, right? And return it, but that would take O(n) for the worst case. However, we can, if we could like sort this array, so we can sort this. Oh, and then we will lose information. We will lose information of the index. Oh, I have a good idea. But it's still O(n) though. I'm thinking of like storing each element and their index to a dictionary, so that when we sort them, we can still have the information to refer to the previous index. But in order to put all this element into a dictionary, we need at least O(n) linear time. What else? I think if we consider this as 0 and consider this as a n-1, where n is the length of the array, we would be able to use binary search. It's kind of tricky. So like for example, first we need to figure out where the arrays start, like where is the smallest number. How do you find the smallest number? That's not. So in this case, we have let's see, 3, 4, 5, 1, 2. So we know that like some part of the array is sorted. So if we do like binary search right here, we look at and we see 5, and we expect that something like behind 5 have to be smaller than 5. So it means that this part is sorted, but this part is not sorted because everything like in front of 5 have to be greater than 5, but in this case it's not. So I guess we can just always look for like a smaller size. Let's try another number, like another sequence. Let's add some negative number. So let's say we have 5 minus 1. Minus 1, 0, 5, 4. So this array is still a sorted array, because as you can see, -1, 1, 2, 3, 4, 5. So you can like go in the middle, look at like the smaller one. Yeah, I think, yeah, we can like figure out the smallest number. So we need to come up with like a algorithm like to find the beginning. So like for this problem, we can like break this down into define, find smallest value. So it's taking A, but doing like some sort of like binary search. So first we need to know the so it's like in binary search we care about low and high. So low should be 0, high should be the weighting of A minus 1. And then yeah, we see 0 and then it's right here, and then we find the mid right here. Oh, yeah. So -1, right? And then we look at 0. So it's like 1. So once we found a number that is smaller than the rightmost element and also like the leftmost element, we can say that that's like the beginning of the array. I mean, another example would be when we have something like, I know, let's see, like 0, 1, 2, 3, some sort of like yeah, so this is a correct shifted left array. So we have 4, 5, 6, 0, 1, 2, 3. So like in this case we check 3 is greater than 0 and 4 also like greater than 0. That's why we can conclude that 0 is like the smallest number. But I wonder if this is a valid input. So initially we have to start with something like this. And then we shift 1. Yeah, I can see that. Yeah, this is a valid input. And whereas let's see, like this case. So initially we start at 4, and then we look at the right. We see this rightmost element is like smaller. It's the smallest. I mean, it's smaller than this. So we change our low from here to here, and then we find out the mid, and we find our smallest value. Is there any keys? Let's say, or if we have just like two elements. Let's say we just have like 0 and 1. So it would be right here. So our mids would be 0. So we check 0. So 0 is less than this, and we check with itself. So basically we tricky. So in this case, like according to my algorithm, it will just pick 0. So 1 have to. So we change our height to right here. Our low is just like here. So in this case, it's the same thing when we have like 1 and 0. So it will pick this. It will move low to here and high to here. So then we pick this index. Yeah. So once we find that index when I and j, like I is basically the left arrow, left pointer, j is right arrow. Once they intersect each other, we can conclude that we find the minimum values. So right here we say while low is less than high, compute mid by doing high plus low. Do like floor division or 2, and then if a mid is less than a and a mid also less than a low, you want to return that index, which is mid. LF a high is less than a high is less than a low. What we want to do is, so a high is less than a low at min. We want to, so our lowest value, our smallest value must be on the right hand side. So we want to change our low to equal to mids. Plus 1. Because we want to move it, we don't want to check the meter again, we already checked that. Else high is equal to minus 1. Alright. I'm a little bit worried about this. So, but our low is always started at 0. I'm thinking about like index error, like just like -1. But it shouldn't, because like low always 0 and we always add low, so it shouldn't give us a like a -1 index. Will it give us out of bound? No, because our high is basically have to be less than n, so this will cut. And then we just return either one, low or high, because after this it means that low and high are equal to each other. Alright, shifted array search. Alright, let's say that we know where the start. So let's say that we have 3, 4, and 5, right? And then we have 1. Let's say that this function gives us like, let's walk through like this and see if it works like what we expect, what I expect. So low is 0, laying would be 5, 5 minus 1 would be 4, so 0 and 4. And right here, mid would be 4 plus 0, 4 divided by 2, so you got 2. And 2 would be right here. So 5. So sim 5, so this condition is not true because 5 is not less than 2 nor 3. So let's look at this. So high, which is 4 right here, and low. So high is less than, so a high is less than a low. So our low have to be moved to mid plus 1. So our low is right here right now. And then we go back one more time. So low is 0 less than high. Low is 0, 1, 2, 3, 3, and 4. And then we do this again. We do 3 plus 4, 7. 7 divided by 2 is 3.5. But since this is floor division, so it should just be 3. So it's going to check here. So checking that. So at this moment, mid and low is equal to each other. So this, it's not true. And then it's checking high and low. So in this case, high is not smaller than low, so it have to take this. So our low currently is equal to 3. High is equal to, initially it was 4, but since we subtract 1, so now it's 3. So then low and high is equal to each other. This is going to be great. So it's going to return low, which is 3. So return a correct index to point to like the smallest value. Alright, I need some space right here. So how would I be able to find a number in a shifted sorted array? Same up before, right? And I think we should make a copy. If we make a copy, it's going to take a lot of time. Um, so we know that, so the idea is we want to remap this whole thing. So we know that actually like 0, 1, 2, 3, 4. So we know that it should be like to use like a sorted, like to use a binary search. We need to think it like this. So how do I convert? How do I convert 0 to 3? So we know that this, like in the original sorted array, 1 should be at index 0, 2 should be index 1, 3 should be index 2, 3 and 4 like this. How do I map this number to this? Wait, did I miss something? 1, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. I feel like I missed something. I think this probably just use like some sort of modular. So if we add everything by 3, like all of this by 3, we will get like 3, 4, 5, 6, 7. And we've modded by 5. No, it's not looking. Oh, it kind of. I mean, I can also see that this is basically just like subtract by 3 by 3, and this is just like adding 2. So it shifted by 2. So yeah, I can find the amount that is being shifted. So it shifted by 2, right? Let me give myself some more space. So in order to find its original place, we just so shift, it means that you subtract it by 2. Oh, I think thinking it shift to the right make more sense. So it shift to the right by, so initially at 1, oh, it was like 1, 2, 3, 4, and 5. I think the question kind of triggers like to think it shift to the left, but shift to the left and the right, it's basically kind of similar. It's just that we just see the amount of step like differently. Like here, you can also view this, like view this as a shift to the right. Three, 4, 5, 1, and 2, right? So basically, we just like shift to the right by 3. So we just add everything by 3 and mod it with 5, because the maximum you can go is 3, 4. Yeah, so if we add everything, so initially this is like 0, 1, 2, 3, and 4, right? So if we add this by 3, so 4 plus 7, 4 plus 3 is 7. 7 modded by 5, we get no. Yeah. So we add everything by 3. All right, one more time. So we add everything by 3. So we have 3, 4, no, yeah, 5, 1, 2. So initially it was 0, and this was 1, as you can see, 0, 1, and then 3 was 2, and this was 3 and 4, and the goal is we want to convert this to 0, 1, 2, 3, and 4. And my proposal is basically just add this number by 3. Yeah, so 1 right here, we get 4, and mod by 5, we will get 1 remainder. And here 3, oh, 4, I mean 4 mod 5 is 4 plus 3 is 3. Yeah, there we go, now we talk. All right, how do we code this? So our low is equal to 0. Our high is still equal to lane of our low is Yeah, our low is 0, our high is, and then we have another function that define convert that take x, and then just do this, return x plus 3, and then mod by length of a 2 plus a right here too. So this will be 3, and this would be what? This would be now we have another challenge. So in this case, our length would be our length would be 4 plus 3 is 7 mod by 5 would be 2, and it's right here. Now we have another challenge. Alright, let me get another piece of paper. So what is that challenge? So in the case that 3, 4, 8, 1, 2, right? So we know where the low is and where the high is. But right now, high is it's smaller than I mean the index at least. So we don't want to measure the index, but we want to measure the value. So let's do C convert this into a different index. Like C here convert basically into a correct index, like where the low and where the high should be. And then while a low is less than a high, so then we calculate our mid. Oh, I see. I think we don't want to convert it right here. Yeah, so just low and high, so no C. Let's see. So this would be while low less than high. So mid would just be the same, low plus high. So we think that we have a perfect rule. We think that our array is sorted in a naive way, in the way that it's not shifted. But when we look up the value, we supposed to convert this index to that value. And then right here, if C mid, so our mid would be right here, index 2. However, we want to convert this into 0. So 2 plus 3 is 5. 5 mod 5 is basically, you know, 0. There we go. Now we talk. So C mid is equal to n, or return. So and then, oh, this is A, and then you want to convert this. And we just return C mid. And right here, you get the idea. So right here, if, okay, let me have some more space right here. And right here, it's basically LF. Would be so we want to compare A mid. So if A mid, and you know, like convert this thing, convert this mid. So if A mid is less than A high, let me rewrite it right over here. Right, so let's call it SA, as taking A and N, and low is 0, high is high of A is 1, and while low is less than high, find mid. It's basically just low plus high divided by 2, and then we just check if n is equal to A. We need to convert this index, like our perfect rule index, to an actual index in the array. So like in this case, mid would be 0 plus 4, which is divided by 2 would be right here. So we get 2, but 2 plus 3 yes, 2 plus 3 is 5. 5 mod 5, just like 0. So we need to convert mid right here. So if this is true, so like somewhere over here, so okay, and right here we just return C mid and LF A of mid less than A of high. So it means that our the number, the element that we're looking for, it's on the left, not on the right. So we need to update our high to be equal to mid. So this is to convert mid minus 1. health low is equal to mid plus 1. What if we have just like one value, like 10? This is, okay, so we need to calculate, it's like on top of here, we need to call this function, find the smallest value. Let's call that, let's store it in S, so find and then we can like every time we call convert, we need to pass this smallest value, because in order, it doesn't know that this is 3. We need to tell it. So 3 is basically where the smallest index is. But I wonder where would be the edge case of this. I wonder, because like in the case that we couldn't find the value, we want to return -1. Return -1. So in the case that we have just like one element, this would be 0. Okay. That's not, so yeah. Equal. So like in this case, it would be, let's say like the number that we're looking for is like, it's 10 as well. So it would be, mid would be 0. And I mean, smallest value would be 0 as well. So it would just be, so n, so it would found it and return C mid right here. C mid just return 0. Yeah, I think it looks great. Let's like run through the example that we given. So example, we're looking for 4, and to find the smallest value, it's in index 3. So we're supposed to return index 1. Alright, so according to our algorithms, like this, as is 3. Okay, it's so our low is 0, high is 5, 4, so 0 and 4, and then it would be 2. So 2 would be right here. However, we need to convert this, so we need to do 2 plus 3, like according to the C formula right here. So 2 plus 3 multiplied by the size of the array, so we will get 0. So it would take this value. So since we're looking for 4, 3 is not the right value, so it keep changing. So like I mentioned earlier, it's think that this is a perfect array. So our high, our low, our high is right here, and going to right here, which is 2. So now since our mid here is less than 4, so since 1 here is since like 5 here is greater than no. So I mean, look at this. So since our mids, it's less than no, careful right here. I think we need to mid less than so we won't change high. I think our mid is greater. Yeah, it's greater than n. So if our mid is greater than n, but 3 is not greater than 4, that's why we need to update our low to here. So our low right now is 3 and high is 4. So we have 3 plus 4 is equal to 7. And what else? And divided by 2, we got 3.5, which is 3. And then this 3 we need to convert it using the convert function. And we got 1. So 1 should be 4, and then that's where we find 4. Like the next iteration is so the next iteration is our low is 3, our high is 4, and we get the index 1, which where we find our 4. So it should return 4 right here. I mean, it should return 1 right here, this index. In the case that I couldn't find it, let's say I try to find, I don't know, 10. So 3, 4, 5, 1, 2, right? So 1, 2, 3, 4, 5. So initially it look at index 2. Then I couldn't find it. So since I couldn't find it, like 3 less than 10, so let's move the low to here, and the high is still right here. And then 3 and 4. So and then the new mid would be 3, and 3 would be like here. So index, so 4 it's still less than 4, it's still less than yeah, 4 is still less than 10. So since 4 is still less than 10, so since 4 is less than 10, so this is, so it's going to do low mids plus 1, so it's going to change low to here. He might have an infinite loop. Oh wait, no, not infinite. So low and high is the same, right? So basically you take 4 plus 4, you divide by 2, so we got 4, right? So 4, 0, 1, 2, 3, 4, 5. 5 is less than 10, so our low needs to be subtracted by 1. No, our low have to be added by 1, so it's going to be 5. So our low is like 5 right here, so it's going to break this loop, it's going to turn to 1. That's it. I think this is right. Yep. Oh, it's about an hour.